The quartile deviation called as QD is defined as Q3 minus Q1 upon 2, and it is also called as semi-interquartile range. Now it's clear why it is called as semi-interquartile range. The word semi stands for division by 2, and interquartile means between the two quartiles Q1 and Q3, and the range is nothing but the larger value minus smaller value. So therefore out of Q1 and Q3, of course Q3 is always larger than Q1, so therefore we do the subtraction and divide by 2. So that is the quartile deviation, which is a measure of dispersion. Okay. We have already seen the method to calculate the quartiles, so let us practice one sum to calculate quartile deviation. Now here the data given is that of the continuous data. We are given classes and their respective frequencies. Now to calculate the quartile deviation, first we must calculate the quartiles, and let us write the formula for ith quartile in general, that is L plus H upon F I n by 4 minus CL. We are already aware of all the symbols here. So if we add up first of all the frequency column to get the total number of observations n, it turns out to be 105, and we have to prepare the cumulative frequency of less than type to locate where the respective number of observations lie. That is, for first quartile we would need n by 4, and for third quartile we would need 3n by 4, isn't it? So let us prepare the cumulative frequency column, starting with 8, then 20, then 40, then 65, 80, 89, 95, 100 and 105, right? So first of all let's calculate what is n by 4. N by 4 is nothing but 105 divided by 4, which is equal to 26.25. So you see the observation coming at the position 26.25, looking at the classes, definitely comes in the third class, because till the second class only 20 observations are covered. Okay, so here we draw a small arrow and mark it as Q1. So Q1 must come in the class 20 to 30. So therefore Q1 is, substituting in the formula now, we have L, that is the lower limit of the class, which is 20, plus class width is 10, and the classes are continuous, so no need to make them again continuous, they are already continuous. F is the frequency of that particular class, which is 20, divided into I n by 4. Now since I is 1, that is already n by 4, which is we have already calculated is 26.25, minus CF stands for the cumulative frequency of the previous class. Coincidentally that is also having the value 20. So therefore on simplifying and solving we will get Q1 as 23.125. That is the value of our first quartile. Now in case of Q3 we have to calculate 3n by 4, because that comes at the 75% mark, isn't it? So 3n by 4 is nothing but 3 into 26.25, and that is nothing but 78.75. So we have to locate the observation which comes at 78.75th position. So once again, looking at the data, it is clear that we must have Q3 in the class of 40 to 50. So this is where Q3 lies. So now we substitute the values. For Q3 the lower limit is 40, plus H is 10 upon frequency for that particular class is 15, into bracket 3n by 4 is nothing but, we just found out, it is 78.75, minus cumulative frequency of the previous class, right? So this we have to keep in mind. The cumulative frequency is always the previous class, minus 65. and here on simplifying we get Q3 as 49.16. So having calculated Q3, we can now calculate quartile deviation. The formula is Q3 minus Q1 upon 2. So 49.16 minus 23.125 whole upon 2, and that finally turns out to be 13.01. So that's the quartile deviation for the given data.